So this video is going to cover section 1.3, which is on graphing points. So in this section, you guys are going to make sure that you can plot ordered pairs and also determine the coordinates of a point. For the ease of today's activity, I'm going to have us skip the explore activity. So we are going to skip that part. There is a question in the practice part of these for section 1.2. So if you jump down to the practice part of 1.3 and you go to page 16, if you go through the practice, that's fine. Just make sure that you don't answer number 3 on page 16. That one you won't have to worry about. It uses the explore problem. All right, so we're going to skip what we have on page 11 and we're going to jump to page 12. So what we're going to be using is called a Cartesian coordinate system, and that's where you have a horizontal and a vertical axis. So graphs using the Cartesian coordinate system are employed often in math and many other disciplines as a way to display paired data and look for relationships. So we're going to be able to answer these questions by the end. Can we explain the Cartesian coordinate system using the correct terminology? And what do all the points on the x-axis have in common? And what about all the points on the y-axis? So in this section, you do have a decent amount of vocabulary and rules, but they should feel familiar to you. Nothing should feel like completely new information. All right, so we're going to first look at this box. It's something that's really important here. Our Cartesian coordinate system is composed of two number lines that intersect at a right angle. And just like we talked about, one is vertical and one is horizontal. The horizontal number line is what we call the x-axis. And so that's this one right here. The vertical line is called our y-axis. The place that they intersect is called the origin, and the origin has the coordinates 0, 0. So the place where we saw the origin, that was at 0, 0. And that's the place where they intersect or they connect. The axes divide the plane into four regions called quadrants, and they're represented by Roman numerals. And the best way that I've explained to students in the past on how to remember your coordinates, or sorry, your quadrants, is to think of it as drawing a C. When you draw a C, you start right here and you go counterclockwise. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4, just like you were drawing a C. So those are your quadrants. And just like I said, you work from the upper right quadrant and you go counterclockwise. Every point in the Cartesian coordinate system has a position described by an ordered pair, and you're going to use the x and y axes to help you figure out the exact placement for your ordered pair. So on your x-axis, from the origin, if you have a placement to the right, it's a positive number. If it's to the left, it is a negative number. For your y-axis, you look at the direction from the origin as far as if it's above or below. So anything above the origin is going to be a positive number for your y. Anything below the origin is going to be a negative number for your y. So one other thing that I want us to add here is what we would do, how we can kind of summarize what the signs will be, whether they'll be positive or negative for each of the points in each of the quadrants. So if you are in quadrant 1, any point in quadrant 1 is going to have a positive x value and a positive y value. And remember that your ordered pairs are first going to describe the x value and then the y value. So in quadrant 1, both of the x and the y values will be positive. Okay, let's look at what they would be for quadrant 2. For quadrant 2, your x values are to the left of the origin. So our x values are now negative, but they're still above the origin, so the y values are positive. Moving on to quadrant 3. Your x values are still negative to the left of the origin, and your y values are now below. So both of these will be negative. And quadrant 4. Your x values are now positive, but your y values are negative. Okay, the other thing that I want us to also take away from this is a specific feature of the x and the y axis. If you have a point on the y-axis, that means that it did not go left or right at all from the origin. It only moved up or down. So the x value didn't change. So if you have a point on the y-axis, your x value will always be 0. You can have the y value be any number, but your x value will always be 0. Looking at the x-axis, if you have a point on the x-axis, it did not go up or down at all because it stayed directly parallel with your origin, all right? So that one is going to have the y value as 0, and your x value will be any number. Okay, those are some important features that you guys will end up using for your coordinate system. So a variable is a letter used to represent an unknown quantity that can take on various values. So for instance, your ordered pair has x and y, which are letters that represent numbers that can change. So here are the directions on how to plot an ordered pair. You're always going to start at the origin, which is where your x and your y-axis meet. You will first move horizontally, so you'll move to the left or to the right. If your first number in the ordered pair is positive, you will move to the right. If your first number in the ordered pair is negative, you'll move to the left. The second number is going to tell you how to move vertically. So if your second number is positive, that will indicate that you go up. If it's negative, that will indicate that you go down. And then you'll just place a dot at that location. So for example 1, plot each of the following points on the graph provided. Write the letter next to the point on the graph. And then we're also right here going to state the quadrant or axis that it's on. Okay, so starting with our first point, 3, 4. Your first number is going to tell you to move left or right. So it's a positive 3, so I'm going to start at my origin right here, and I'm going to move to the left 3. So right now I moved to this spot right here, but I also need to show my point going up 4. Because your second value is a positive 4, you're going to move up 4. So I'm going to take from there and go up 4. You also want to make sure that you label your point so that you can tell which points are which on your graph. Okay, the second part of the problem is to identify the axis or the quadrant that it's in. Remember, you're going to draw your C to remember which quadrant is which. So this one starts with 1, 2, 3, and 4. If you are not comfortable writing your Roman numerals and you just want to write the numbers 1, 2, 3, and 4, that is fine. Don't worry. So this point A, is in quadrant 1. So I'm just going to write Q1 to just abbreviate quadrant. For number or letter B, we have 5, 1.7. So I am going to start from my origin right here, and I'm going to go 5 to the right because that's a positive 5. So start at the origin and count 5 to the right. So right now I'm there. And then I'm going to move up 1.7. So that's going to be almost at 2. Okay, and label that as point B. This one also had both positive values for the x and the y, so it makes sense that this one is also in quadrant 1. For C, we're going to move to the right for the 2 value. So I'm going to start my origin and go 2 to the right. Now the second number is a -4, so that means I'm going to go down 4. So I end up right here. Label that as C, and we can see that we are in quadrant 4. For D, this one might look scary because it has a fraction. It shows -5/2. But we learned in section 2 that to change it to a decimal, it's just pretty simple. All we have to do is divide. So in our calculator, we can do -5 divided by 2, which is -2.5. So just replace the -5/2 by -2.5 if that kind of intimidates you. Okay, so start at your origin. The first number is a -2.5, so we're going to be right in between -2 and -3, and then we're going to go down 4. So this will not be exactly on a grid point, but that's okay. We don't want it on a grid point because it's in between -2 and -3. Okay, so that is point D, and we can see that's in quadrant 3. For E, this one has a 0 in it, so make sure to pay attention to that. When we have zeros in our points, that indicates to us that it's either going to be on the x-axis or the y-axis. So remember, if you have a point on the x-axis, that means it didn't go up or down at all. So your y value will be 0 and x will be a number. It's the opposite if you have a point on your y-axis. Your x value will be 0 and your y value will be any number. So looking at E, this tells us we're not going to go left or right at all. We're only going to go up 1. So I'm going to start at the origin. Don't go left or right at all, and just go up 1. So that is point E, and we can see that's on the y-axis. This also confirms it because we have a 0 for the x value. So it is on the y-axis. The last problem is -3, 0. So you're going to go to the left 3, and then you're not going to go up or down at all. So start at the origin, go to the left 3, and don't go up or down at all. So that is F. And we can see that's on the x-axis, and we also know it's on the x-axis because the second number is a 0. So that's how you're going to take an ordered pair and plot it on your graph, and also identify which quadrant or which axis it's on. Okay, looking at these ones, you're just doing it the opposite way. Now we are given points, and we're now going to name the coordinates and say which axis it's in. So you still, when you look at when you're trying to find the coordinates of an ordered pair, you're still going to think about where it is in relation to the origin. So looking at letter A, we first want to identify if it went left or right. So it went to the right, and we can see that it went to the right 2, and we also see that it went up, and it went up 3. So both are positive. So the point for A would be at 2, 3. This is quadrant 1, 2, 3, and 4. So we can write quadrant 1. For point B, when I look at where it is from the origin, I see that it went to the left 4. So my x value will be -4, and it went up 1. So a +1 for the y. That one is in quadrant 2. For C, from the origin, it went down 5 and to the right 1. So -5. Oops, I did that one out of order. It can happen to anybody. So first go left or right. So we see it went to the right 1, and it went down 5. So 1, -5. And we've got it in quadrant 4. Your last one will be D, and you can see that this one is on the x-axis. So on the x-axis, the y value will be 0 because it didn't go up or down at all. So we already know for that part of our coordinate, it's going to be 0. And we just need how far left it went. So it went left 2, so that would be a -2, and it was on the x-axis. For this problem, it says to connect, we're going to be using the graph below from a study on Facebook. And this kind of graph that we see here is called a scatter plot. That's where you have points plotted, but they're not connected. It shows the amount of time spent on Facebook is related to college GPA. So what it did was it took individuals, and it has each point representing one person's amount of minutes they spent daily on Facebook and what their GPA is. So it shows the relationship then between minutes on Facebook and GPA. And what we can see here is when we read the graph, we're going to read it from left to right. So we can see that when we go from the left to the right along the x-axis, the amount of minutes spent on Facebook increases. So if we read from left to right, we can see that the points, when we move from left to right, are going down. So we can see that there is a relationship that shows as the minutes spent on Facebook daily increases, the GPA decreases. So the scatter plot gives the impression that GPA falls fairly significantly as the number of minutes spent on Facebook increases. This impression is influenced in part by the scale on the y-axis, which ranges from 2.5 to 3.0. So it has an increase of 0.1 for the GPA every single dash or tick mark that you see. One thing that we're going to touch on when we get to our section on scatter plots later on, is a jagged start along the y-axis. So you can see that there's a jagged start right here. What that means is we skipped a lot of values, because if we started at 0 here, we started at 0 and we were increasing by increments of 0.1, we would have 0.1, 0.2. It would keep going and keep going. Then we'd have 1.0, 1.1. And then we'd eventually get to 2.5 and 2.6 and so on. But a lot of these values are skipped. So if we have values skipped like that, it can be shown that those values were skipped by just including this jagged start. So what we want to do is we want to have a little bit less of an influence by the scale. So what we're going to do is, and when we think about GPA, our GPA range can be between 0 and 4. So when we think about the overall range of a GPA between 0 and 4, if we're including only the numbers between 2.5 and 3, that's really only including a small part of the overall range of GPA that we could have. So we want to see what will happen to the scatter plot if we create it to have a scale from 0 to 4. So all we're going to do is we're going to take the points that were included in the original scatter plot and we're going to use them in our new one. Okay, so it says to redraw it, we're going to have our y-axis be between 0 and 4, and it's going to go up by an increment of 1. So let's go ahead and first do that. So we start at 0, we're going to go by 1s. Okay. You want to make sure that you include all of the details here as well. So you want to include labels and a title. So we want to include that these numbers, are for our GPA. And when we do the numbers along the bottom, we want to show that this is the minutes spent on Facebook daily. Okay. And it didn't ask us to change those, so we can just keep those the same. 100, 200, 300, and 400. And we'll do a title. We can keep it the same. Facebook usage in GPA. Okay. Last thing we want to do is plot our points. So looking at the first one, this one right here, that point is a little bit more than 100 minutes and it's close to 2.9. So a little bit more than 100 and it's going to be really close to 3. Okay, the next point is a little bit further from 200 and it's a little bit more than 2.8. So there, and it's going to only be a little bit lower because remember, this whole gap here is between 2 and 3. The next point is a little bit less than 300 and right around 2.7. So again, it's only going to be decreasing in height a tiny bit. This next one is a little bit past 300 and it actually went up a tiny bit, but when we have it on this scale, it's really not even going to be visible. And the last one is almost at 400 and at 2.5 for the GPA. So it's going to be directly between 2 and 3. Okay. Now, what we want to do then is look at this graph and try to take away any bias that we have from looking at the previous one. So let's comment on the impression the new graph gives us about the relationship between GPA and time spent on Facebook. Well, if we look and read this from left to right, we can see that the amount of minutes spent on Facebook daily is increasing, but the steepness of the line here is not really that dramatic. We're not really seeing a huge change. So the impression that this one gives us is that, well, dang, if you're spending more time on Facebook daily, your GPA is going to be much lower. The impression that this one gives, by us changing the scale of the y-axis, is that it's not really affecting it much more. So we can see that the scale creates a large difference. So a comment on the impression that this one gives us is that it is not as apparent that time spent on Facebook negatively affects, or you could say lowers, GPA. Okay, if you guys would find it useful, remember that your practice problems start on the next page, so page 15. Remember to skip number 3.